first photograph of Neptune taken with NASA's James Webb Space Telescope brings the planet closer to Earth. Webb sensors not only capture the clearest glimpse of this faraway planet's rings in more than 30 years, but also provide new insight into the ice giant. Is there a secret goal of the James Webb Telescope? In Webb's most recent picture of Neptune, the ice giant, what do we see? Don't go anywhere, we've got all the details for you in this video. Please subscribe to the Future Space as well. Then, let's not waste any more time and get down to the video. Let's begin by discussing the primary purpose of the James Webb Space Telescope is infrared astronomy. It is the largest optical telescope in space and can see objects that are too distant, too faint, or too early for the Hubble Space Telescope because of its superior infrared resolution and sensitivity. This will allow astronomers and cosmologists to observe the birth of stars and galaxies, as well as characterize the atmospheres of possibly habitable exoplanets, among many other investigations. JWST was designed and developed under the leadership of NASA, in collaboration with the European Space Agency and the Canadian Space Agency. Northrop Grumman was the prime contractor, and NASA's Goddard Space Flight Center in Maryland oversaw telescope development. JWST is operated by the Space Telescope Science Institute on the Homewood campus of Johns Hopkins University in Baltimore. James E. Webb, NASA administrator during the Mercury, Gemini, and Apollo programs, is honored by the naming of this telescope. On December 25, 2021, an Ariane 5 rocket lifted off from Kourou in French Guiana, carrying the James Webb Space Telescope toward the Sun-Earth L2 Lagrange point. It reached its destination in January 2022. On July 11, 2022, a press conference was held to unveil the first image from the JWST. The primary mirror is made up of 18 hexagonal mirror segments composed of gold-plated beryllium, and its final diameter is 6.5 meters, which is significantly larger than Hubble's 2.4 meters. This makes JWST almost 6 times as sensitive as Hubble, with a light collecting area of about 25 square meters. JWST, in contrast to Hubble's near-ultraviolet and visible and near-infrared spectra, observes in a lower frequency range, from long-wavelength visible light through mid-infrared. For the telescope's own infrared light not to contaminate the captured light, temperatures of 50 Kelvin or below must be maintained. Its 5-layer sunshield prevents overheating from the Sun, Earth, and Moon while it orbits the Sun at a distance of around 930,000 miles from Earth. The Next Generation Space Telescope project kicked off in 1996 with preliminary concepts. In 1999, with a possible launch date of 2007 and a budget of $1 billion, 2 concept studies were commissioned. Construction was finally finished in 2016 at a total cost of $10 billion after years of delays and massive cost overruns that led to a radical redesign in 2005. Scientists, reporters, and engineers all commented on how intricate the telescope was and how much was riding on its successful launch. Now let's talk about the JWST's recent revelation of insane Neptune images. Webb's latest image is startling because it clearly shows the planet's rings, some of which have not been seen since NASA's Voyager 2 flew by Neptune in 1989. In addition to many prominent slim rings, Webb's image of Neptune also reveals the planet's fainter dust bands. Heidi Hamel, an expert on the Neptune system and an interdisciplinary scientist for Webb, observes that it has been 3 decades since we last observed these weak, dusty rings, and that this is the first time they have been spotted in the infrared. Webb's consistent and precise imaging enables the detection of these tiny rings so near to Neptune. Since its discovery in 1846, Neptune has been a source of fascination for scientists. Neptune orbits in the distant, dark reaches of the outer solar system, which is 30 times farther from the Sun than Earth. High noon on Neptune is like a dull twilight on Earth, since the Sun is so small and feeble at that far distance. Because of its chemical composition, this planet is classified as an ice giant. Neptune has a greater abundance of elements beyond hydrogen and helium than either Jupiter or Saturn, the other gas giants. Small concentrations of gaseous methane give Neptune its distinctive blue color, as seen in photos taken by the Hubble Space Telescope at visible wavelengths. Since the near-infrared band of 0.6 to 5 microns is where Webb's near-infrared camera captures photos, Neptune does not seem blue to Webb. In fact, except for regions with high-altitude clouds, the planet appears quite dark at near-infrared wavelengths because methane gas substantially absorbs red and infrared light. These methane ice clouds reflect sunlight before it is absorbed by methane gas, making them visible as bright streaks and patches. These fast-changing cloud characteristics have been captured in images from other observatories like the Hubble Space Telescope and the WM Keck Observatory. Neptune's winds and storms are powered, at least in part, by global atmospheric circulation, which may be visually seen as a brilliant ring around the planet's equator. Atmospheric infrared emission is enhanced because the atmosphere warms and sinks toward the equator. Because of Neptune's 164-year orbit, the planet's north pole is obscured in this image. However, the Webb photographs suggest an unusual brightness in this region. Webb's perspective shows a vortex at the southern pole, which has been seen before, but for the first time, Webb has shown that it is surrounded by a continuous ring of high-altitude clouds. Webb was also successful in photographing 7 of Neptune's 14 known moons. It's not a star, but an extremely brilliant point of light dominates this Webb photo of Neptune, complete with the characteristic diffraction spikes found in many of Webb's images. That's Triton, Neptune's massive and peculiar moon. Typically, over 70% of the sunlight that strikes Triton is reflected due to its surface being covered in a frozen sheen of condensed nitrogen. Methane absorption at these near-infrared wavelengths causes the atmosphere of this planet to darken, making Uranus appear much brighter in this view than Neptune. Due to its peculiar retrograde orbit, astronomers believe Neptune's moon Triton was originally a Kuiper Belt object that was trapped by Neptune's gravity. In the next year, additional Webb observations of both Triton and Neptune are scheduled. When it comes to studying the cosmos, no other observatory compares in quality to the JWST. Webb will investigate the origins and structure of the universe, as well as the existence of additional worlds outside our solar system. Webb is a collaborative international effort between NASA, the European Space Agency, and the Canadian Space Agency. A meeting at NASA to discuss Webb telescope alignment. NASA will hold a media teleconference on Monday, May 9th at 11 a.m. Eastern to update the public on the JWST's readiness for science operations. The teleconference will be broadcast live on the agency's website. From the solar system to the farthest galaxies in the early cosmos and everywhere in between, Webb will investigate the full gamut of cosmic history. The recent completion of mirror alignment will be discussed, as well as what the remaining months of Webb's science instrument preparations will entail. Involved in the teleconference are Goddard Space Flight Center's Webb Observatory project scientist Michael McElwain, scientist on the Webb project at the European Space Agency Christopher Evans, senior mission scientist in space astronomy at the Canadian Space Agency Jean Dupuy, Marcia Reike, a Regents Professor of Astronomy at the University of Arizona and the main investigator on Webb's near-infrared camera, project scientist for the Webb telescope at the Space Telescope Science Institute, Klaus Pontoppidan. Media interested in asking questions during the teleconference should RSVP to Laura Betts at laura.e.betts@nasa.gov at least 2 hours before the event. The guidelines for media accreditation at NASA can be found on the agency's website. The Webb team was able to effectively capture starlight via all 18 mirror segments in early February. The 7 steps of mirror alignment took place over several months when Webb's research instruments reached their operational temperatures. As of late April, when the final phase was completed, all 4 of Webb's science instruments were able to take clear, focused photos. The next 2 months will be spent on instrument commissioning, the process of preparing and testing the research equipment, before Webb's first science images and spectra are released this summer. The NASA website provides a digital media kit, photo galleries, and video libraries. Likewise, a Where is Webb interactive tracker allows the public to monitor the spacecraft's location. Webb was launched on December 25 from Europe's spaceport in Kourou, French Guiana. Webb is a joint project between the European Space Agency and the Canadian Space Agency. The observatory is currently through the months-long process of preparing for science operations after successfully unfolding into its final form in space and arriving at its destination 1 million kilometers from Earth. When it comes down to it, what do you think the James Webb telescope is trying to find? Please tell us in the space provided below. That's all I have for you today, folks. We hope the video was entertaining. The patronage of our audience is essential to our success. To that end, we encourage you to subscribe to our channel and stay tuned for more incredible critiques.